Now I have to ask the question about whether there are substantial arguments from a thermodynamic perspective that I can make. It turns out that dissolving oxygen in water is an exothermic process. Delta H is negative. That means then that I'm giving off heat. We'll be learning soon enough about Le Chatelier's principle. And Le Chatelier's principle tells us that when you have a system which is at equilibrium and you apply a stress to it, the system acts to move away from that stress. So looking at this case right here, if I have a system which is a beaker and it's got some oxygen sitting in it and I heat it up, that means that I'm stressing the system by adding heat to it. So the heat is not favored. It doesn't want to produce heat. It wants to get cooler. It wants to move away from that stress. So the system says, I'm going to move back to the left to get away from that stress. I'm going to move to make myself cooler to get away from that stress. But to get cooler, to move away from that stress, means to remove the oxygen from the solution and make a gas. See, that's what happens when I move back to the left. Stress comes to the system acts against the stress, and oxygen leaves. In other words, as the temperature goes up, the oxygen leaves. It becomes less miscible, less soluble in water. Well, one practical thing that we know about this is something we see all the time when we're at home cooking our spaghetti. We put our water on to boil, we heat it up, and we immediately see these little bubbles that tend to cling to the sides. This is well before boiling happens. You know what those little bubbles are? Those little bubbles are oxygens which are being driven out of solution. As those oxygens are being driven out of solution, they first start to cling to the sides here, and then they later are evacuated from the system. This is the process of heat going in, the stress from the heat going in, making the system fight the heat by moving back to the left and producing gas. So this says that as temperature goes up, the solubility of oxygen in water goes down. Temperature goes up, solubility of oxygen in water goes down. Now let's think about those implications out in this big wide world we live in. This says that if I'm comparing what it's like to be a fish swimming around in the ocean in the Arctic and a fish swimming around in the ocean in the tropics, there's actually more oxygen dissolved in the water in the Arctic than there is in the tropics. This also says that if all else is equal, and from year to year I'm a fish trying to get my air as I live in the tropics, if some sort of climate change occurs and it gets hotter overall, then there is less oxygen in the water. And if there's less oxygen in the water, there's less air to breathe for the fish, and then they die. And so people make arguments that by raising the temperature of the water, you decrease the aerobic action, like fish breathing and normal kinds of plants that need oxygen being able to grow, and you increase the anaerobic action, and you produce things like red tide. So you can actually see on this chart here this reality that I just talked about. This is comparing a 25-degree solubility for oxygen with a 50-degree solubility. And you'll notice that even though it's a relatively slight change that's occurring, and obviously this is a rather substantial increase in the temperature, going from this room temperature value of oxygen dissolving in water, 0.0041 grams per liter, it goes down significantly as I go to 50 degrees because this is an exothermic process.